At precisely 0420 hours local time, a squadron of 9 Ukrainian combat drones glided silently through the pitch-black sky over the Crimean Peninsula. They were closing in on one of the very last critical Russian logistics rail arteries that had managed to escape Kyiv's strike campaigns. Traveling along the Moscow-Simferopol line, a massive 21-car train was transporting a payload of over 1,200 tons of artillery shells and 800 tons of fuel destined for forces in Crimea. For Moscow's high command, this transport was far from a routine transit. It represented an absolute lifeline for their regional regiments, which were facing a worsening depletion of ammunition and fuel after weeks of Ukrainian blockades and military isolation. Yet, what the Russian forces did not realize was that within the next 90 seconds, this entire highly volatile cargo would be transformed into a colossal inferno right at the entrance to Crimea. This devastating blow would unfold in the exact location where they believed their air defense shield was completely airtight and impenetrable. To execute this surgical strike, Ukrainian forces deployed a perfectly synchronized fleet of 11 aerial platforms. Hovering at an altitude of 9,000 feet, roughly 6 miles from the collision zone, an Autel EVO II Dual 640T reconnaissance UAV monitored the entire train in absolute silence. A second identical drone remained on standby nearby, prepared to launch instantly if the primary asset suffered a hardware failure, signal loss, or enemy jamming. Meanwhile, the striking force was composed of 9 highly agile, high-speed FPV drones. The choice of this specific observation platform was deliberate, as it circumvents virtual geographical barriers geofencing and is far stealthier than standard civilian drones. Its dual optical sensor enabled continuous surveillance through both day and night. Its thermal imager, featuring 640 and 512 resolutions, mapped the heat signatures of the locomotive and the fuel tankers, while the 48-50 megapixel optical lens provided crystal-clear details to identify precise targets. The aircraft is capable of staying airborne for 38 minutes, reaching speeds of 50 miles per hour, transmitting data up to 10 miles away, and ascending to a ceiling of 15,000 feet. Additionally, it can withstand wind gusts of up to 40 feet per second, maintaining a rock-solid hover directly over the tracks. Its 19 integrated sensors and multi-satellite receiver, combining GPS, Galileo, Beidou, and GLONASS, allowed it to lock its geographical coordinates while continuously feeding real-time updates of the train's path to the 9 approaching strike drones. Conversely, the FPV drones were compact, highly sophisticated machines designed for maximum maneuverability during the assault phase. These 9 single-use devices were assembled in Ukraine specifically for this suicide mission. They relied on 10-inch propellers paired with 4 brushless DC electric motors. Each aircraft carried a 7-pound penetrating warhead and could dive at speeds exceeding 90 miles per hour. Power was supplied by a 6S battery pack engineered to deliver high current bursts during rapid acceleration phases. The flight controller, running customized Betaflight software, instantaneously balanced motor output and aircraft pitch to stabilize the drone during low-altitude flights or sharp course corrections. Their entire engineering architecture served a single objective: to survive defensive anti-aircraft fire in the final meters, crash precisely into the targeted cars, and trigger catastrophic chain reactions. Inside a forward command post located 23 miles from the ambush site, Ukrainian operators analyzed live thermal footage transmitted by the Autel EVO hovering above the convoy. Against the cold ground of the Crimean Peninsula, a long, glowing heat signature stood out sharply on the screens. The observation drone's thermal lens, equipped with a 13mm focal length and 16x digital zoom, maintained a continuous visual lock on the target. As the diesel locomotive made its way south, its engine emitted a prominent heat signature, while the fuel cars appeared noticeably warmer than the surrounding environment. This thermal data stream allowed operators to track the convoy's progress without relying on any visible light source. The imagery, geographical coordinates, and thermal data were immediately routed to the command center via a highly encrypted data link. This secure communication channel drastically reduced the risk of interception or detection by Russian electronic warfare units during this pivotal phase. Barely 4 seconds later, the battle computer began modeling the interception vector for each individual asset. The convoy's position, speed, heading, and the ideal attack profile were synchronized and sent instantly to the 9 FPV pilots waiting for the order to strike. However, the absolute key factor for the Ukrainian staff was temporal precision. For the 48 hours leading up to the assault, a covert network of agents operating near the Moscow-Simferopol railway monitored Russian logistics flows without interruption. Through these intelligence reports, they discovered a critical vulnerability. This supply train was required to slow down and halt for exactly 1 minute at the Taman checkpoint for anti-sabotage security screenings. This brief pause created a window of opportunity with the highest probability of success. As the train slowed to under 10 miles per hour and came to a stop, the tankers and ammunition cars became stationary targets, making them easy to lock onto for the strike drones. Once the targets were confirmed, the 9 FPV drones simultaneously transitioned into terminal attack mode. Each carried a 7-pound shaped charge designed to detonate on contact. This munition was calibrated to pierce the 15mm steel armor of the railway cars and tankers before detonating inside the compartment. A single successful penetration into the correct tank or cargo car would amplify the blast, propagating the shockwave through the tightly packed fuel and artillery shells. The moment the target was validated by optical and thermal feedback, the lead pilot pushed his throttle forward. The drone pitched down, broke away from the formation, and dived toward the moving train. Above the scene, the Autel EVO tracked the locomotive closely. Any minor shift in speed or direction was instantly encrypted and relayed to the command post, which immediately corrected the flight paths of the striking drones. However, the maneuver was far from simple. Following previous drone strikes on its supply lines, the Russian military had modified its transport protocols. The train engineer repeatedly alternated between sudden accelerations and sharp braking. This tactic was designed to prevent drone operators from predicting a car's exact position at the moment of impact, as even a tiny variation in speed could shift the collision point by dozens of feet. Inside the pilot goggles, the video feed from the forward camera shook as the FPV hugged the railway line. The digital stabilization software fought to keep the fuel car centered in the crosshairs, while the reconnaissance drone provided the latest speed corrections. With every surge of the locomotive, the aiming reticle was immediately shifted forward. Conversely, whenever the train braked, the FPV pilot had to shallow his dive angle to avoid overshooting the target. As the distance closed, the reconnaissance team kept their eyes locked on the monitors. The Autel EVO followed the train through every bend, confirming that the fuel tankers and ammunition cars remained in the exact configuration mapped out by military intelligence. The final telemetry reached the command post, and the approach vectors were now fully stabilized. The operator requested permission to strike, and the mission commander validated the final visual parameters before giving the green light. But just as the order was about to be transmitted, an unexpected event disrupted the entire plan. Just 3 miles from the railroad tracks, a Russian R-330Zh Zhitel electronic warfare station powered up to maximum capacity. The convoy had just entered an electromagnetic jamming envelope previously set up by Russian forces. This heavy system, mounted on a military truck chassis, is designed to jam radio communications and satellite positioning signals within a 12-mile radius. As soon as it detected abnormal radio emissions around the train, the device saturated the airwaves across multiple frequency bands to disable the drones or throw off their navigation without the pilot's knowledge. Inside the Ukrainian command bunker, the control interface flagged severe interference and warned of unstable data links. Command latency spiked, and the live video feeds from the FPVs began to freeze frame by frame. The pilots reported massive jamming on their main control channel. At first, the Russian operators blanketed the area with wide-spectrum jamming to sever all contact between the drones and their ground station. Seeing that this was not fully effective, the Zhitel technicians shifted to a much more aggressive tactic. They swept several broadband frequency ranges simultaneously. Once they isolated the Ukrainian signals, they concentrated their entire jamming output onto 2 specific analog bands, 1.2 GHz and 5.8 GHz. which are widely used for video transmission and control of modified commercial drones. If this worked, the 9 FPVs would lose their video feeds at the critical moment of impact and be rendered useless. However, Ukrainian engineers had anticipated this exact scenario. Instead of transmitting on a fixed channel, the communication systems on both the Autel EVO and the 9 FPV drones hopped frequencies randomly up to 124 times per second. Every time the Zhitel system locked onto a frequency, the entire control network had already jumped to another channel within the encrypted band. Although the operator's screen showed minor static, the link was never completely broken. Realizing that conventional jamming was failing to halt the threat, Russian forces played their final card. The Zhitel system began broadcasting spoofed GPS signals to trick the drone's onboard computers into believing they were in a different location, slowly pulling them off course without the pilots realizing it. Yet, barely 5 seconds later, the Ukrainian navigation suite detected the positioning anomaly. The altered data did not match the accelerations and actual trajectory recorded by the Inertial Measurement Unit, IMU, built into each drone. The onboard processor immediately flagged the satellite signals as corrupted, discarded them from the navigation loop, and switched to a backup positioning mode combining inertial data and visual tracking from the nose camera. Despite the jamming alerts flashing on the command screens, the 9 drones held their formation and continued closing the distance to the train. On board each FPV, the visual inertial navigation system took over autonomously. The accelerometers and gyroscopes continuously measured changes in velocity, heading, and attitude, allowing the drone to calculate its precise position even without GPS. Despite the total loss of satellite signals indicated on the control screens, the flight paths of the 9 FPVs did not drift by an inch. Instead of relying on GPS, the AI-driven system compared the nose camera's feed with topographic maps previously logged by the Autel EVO. Tree lines bordering the tracks, power poles, and roadside infrastructure served as visual landmarks for the autopilot. Each drone continued to track the rails as if it were experiencing zero external interference. A few seconds later, the lead FPV's camera captured a crucial detail, the sign marking the anti-terrorist security inspection zone at Taman. This was the exact spot Ukrainian intelligence had been watching for days. Below, the Russian locomotive began applying its brakes, and the train slowed down progressively. In the Ukrainian command post, every eye locked onto the monitors. The moment they had been waiting for was finally here. As soon as the convoy's speed dropped to the target threshold, the automatic target recognition algorithms activated simultaneously across all strike drones. Trained on thousands of images of Russian railway equipment, the system instantly identified the locomotive, the fuel cars, and the ammunition compartments, calculating the precise spacing between each carriage. In a fraction of a second, each drone's processor determined the optimal impact point to maximize damage while assigning a unique target to each unit to prevent multiple drones from hitting the same spot. But time was running out, as the train would remain stationary at the checkpoint for only 1 minute before resuming its journey into Crimea. The Ukrainian operators had just one shot before their target moved out of this ideal bottleneck. Now, the FPV drones had locked onto their respective targets and were merely waiting for the final authorization from the command post to initiate their terminal dives. At exactly 0426 hours and 20 seconds, the attack order was transmitted to the lead unit in the formation. 2 FPV drones immediately pitched down, pushed their 4 motors to a dive speed of nearly 200 feet per second, and descended on a car near the rear of the train. On the forward camera feed, the target appeared as a heavy steel carriage covered by a reinforced tarp. Utilizing its shape and position within the convoy, the recognition algorithm confirmed it was a high-value military cargo compartment transporting weapons. 5 seconds later, the first FPV slammed directly into the center of the targeted car. Its 7-pound warhead detonated instantly on contact, shooting a jet of molten metal that punched straight through the steel plating before triggering the main explosive charge inside. A brief flash lit up the night as metal fragments and car body parts were thrown to both sides of the tracks, but the massive secondary reaction Ukraine hoped for did not materialize. The cargo, consisting primarily of small arms packed in wooden crates and secured by steel brackets, absorbed the blast without spreading the fire to adjacent cars. Inside the locomotive cab, the engineer immediately realized they were under attack. He threw the throttle to maximum, trying to drag the convoy out of the inspection zone before the remaining drones could strike. The powerful diesel engine roared, the steel wheels spun against the tracks, and the 21 heavy cars lurched forward in a desperate attempt to escape toward Crimea. Above the convoy, the Autel EVO quickly confirmed that the first strike had failed to trigger secondary detonations. The thermal feed showed only a localized fire at the rear, while the primary ammunition carriages and fuel tankers remained intact. This information was beamed back to the command center in real time. Although the first blow had connected, the train retained its ability to move. The Ukrainian commander ordered the remaining units to continue the pursuit before the convoy could build up speed and escape the ambush zone. However, the initial impact had severely warped the steel frame of the rear cargo car. A large section of torn metal was hanging down, catching on the wheel assembly and scraping violently against the rails. With every attempt to accelerate, this piece of metal dragged along the tracks, throwing out massive showers of sparks and generating immense drag. The locomotive continued to roar at full power, but the train struggled to gain speed. It crawled forward at a walking pace as the 7 remaining FPVs began their final descent. The drones deployed at an altitude of 15 feet, flying along the tracks at over 100 miles per hour to catch up with the train at exactly 0427 hours. Above them, the reconnaissance drone maintained its visual lock. Its thermal camera scanned the 21 cars continuously, distinguishing the damaged areas from the high-priority targets that remained untouched. Within seconds, the Ukrainian combat system selected 2 critical targets, the 5th car from the locomotive and the 10th car located near the center of the column. The 5th car was identified as a high-capacity fuel tanker. At 0427 hours and 20 seconds, 2 strike drones broke away from the group and closed in on it from different angles. The first accelerated past 90 miles per hour and struck the flank of the tanker dead center. The second maintained a lower trajectory, targeting the bottom drain valve where the steel casing was thinnest and the fuel lines were most vulnerable. The 2 penetrating warheads detonated almost simultaneously. The plasma jets punched through the 15mm steel armor, causing the main charges to explode inside the tank. The pressure inside surged to extreme levels, tearing the tanker's structure apart and vaporizing the fuel into a highly volatile mist. At the center of the explosion, temperatures rapidly climbed past 2,000 degrees Celsius. A 60-foot wide fireball swallowed the car as a column of flame shot more than 100 feet above the tracks. The shockwave violently shook the locomotive cab windows and pushed fire into the adjacent cars. A few seconds later, the intense heat began to boil the fuel in neighboring tankers. Internal pressure spiked, rupturing safety valves and venting jets of burning fuel vapor across dozens of feet. The first secondary explosion detonated shortly after, spreading the fire to 4 additional cars and transforming the front of the train into a 300-foot-long tunnel of fire. The optical imagery from the surveillance drone began to blur under the thick black smoke and thermal distortion, forcing the Autel EVO operator to switch entirely to the thermal channel to continue guiding the attack on the remaining intact cars. At the same moment, around 0427 hours and 43 seconds, 2 other FPVs dived at nearly 100 miles per hour toward the 10th car. But the convoy suffered a violent lurch caused by the warped metal of the rear car continuing to drag on the tracks. This abrupt braking action shifted the target car's position by several feet in barely a second. Both drones lost their lock, missed the car, and crashed into the coupler system connecting the carriages, exploding in the open air without causing significant damage. The next 2 FPVs immediately took over to complete the mission. They abandoned the 10th car and locked onto the ammunition carriage directly behind it. The first unit struck the center of the cargo compartment at 0427 hours and 50 seconds, tearing a hole through the metal wall. Less than a second later, the second drone flew precisely into the newly made breach, detonating its warhead inside the carriage. The initial blast produced only a modest 20-foot flare, but within 2 seconds, the extreme heat and metal fragments triggered the artillery shells stored inside. A rapid chain of secondary explosions literally tore the railcar apart. The blast wave threw steel plates weighing hundreds of pounds into the air, while the roof of the car was blown more than 40 feet upward. Incandescent shrapnel rained down far on both sides of the tracks. The temperature at the core of the blast reached 2,000, 500 degrees Celsius instantly, and a 150-foot column of fire erupted into the sky, merging with the burning fuel tankers to create one continuous, massive blaze. Yet, the operation was not over. The final two FPV drones turned their sights toward car number 18, a key military hardware compartment at the rear of the train. This was the only section of the convoy that had so far escaped the consuming flames of the previous strikes. At 0427 hours and 57 seconds, the last two drones descended to an altitude of 10 feet and accelerated through the wall of smoke and falling debris over the tracks. The first FPV breached the outer wall, followed less than a second later by the final unit, which entered the opening to detonate its charge in the heart of the compartment. A massive fireball erupted at the rear of the train, tearing car number 18 open and sending a thermal shockwave in both directions along the column. The fire dome expanded to 100 feet wide, as an immense plume of smoke and fire rose more than 160 feet above the site. Now, the convoy was no longer burning from isolated spots. It was ablaze simultaneously at the front, middle, and rear. In less than 40 seconds after the first impact, the three separate fire zones merged to form a single continuous line of fire hundreds of meters long, engulfing almost the entire train. This surgical strike on Car 18 sealed the fate of the Russian logistics convoy. By 0428 hours, the train carrying 1,200 tons of artillery ammunition and 800 tons of fuel was entirely trapped in the flames. Temperatures at the core of the wreckage still exceeded 1,000 degrees Celsius in multiple areas, and the columns of fire illuminated the entire entrance to Crimea. This massive fire at the gateway to Crimea did more than just reduce a supply train to ash. It struck a devastating blow to the vital logistics artery that Russia relies on to keep its troops combat-ready in Crimea and across the entire southern front. Over 800 tons of fuel, and the majority of the 1,200 tons of artillery projectiles were consumed, exploded, or now lay buried under the charred, warped carcasses of 21 ruined carriages. The extreme heat of the fire, which sustained itself above 1,000 degrees Celsius, literally bent the steel rails, charred the wooden ties, and cracked the concrete ballast beneath the tracks. The presence of unexploded ordnance and hazardous metal fragments scattered across the site prevented Russian crews from simply towing the wreckage away to quickly reopen the line. Before any rail traffic can resume, Russian military engineering units will have to extinguish the remaining fires, clear the area of explosive hazards, remove the remnants of the destroyed cars, and completely rebuild the rail bed. This heavy repair work could take days or even weeks, especially since recovery crews will have to operate under the constant threat of another Ukrainian drone strike. Disrupting a single section of track is enough to create a severe logistical bottleneck. All military trains behind the incident point are blocked, halting the scheduled delivery of shells, fuel, armor, and spare parts into Crimea. While Moscow may attempt to shift this freight to truck convoys, transport capacity will drop drastically. To make up for the loss of a single 21-car train, the Russian military will have to mobilize dozens, if not hundreds, of trucks, while finding drivers, additional fuel, and military escorts to protect them. These road convoys will have to use the Sea of Azov corridor, a route where they are far easier to spot and target by Ukrainian artillery, missiles, and drones. The fallout from this strike will quickly be felt on the Zaporizhia and Kherson front lines. Crimea serves as the primary logistical staging ground for Russian forces operating in southern Ukraine. With the supply flow severed, forward ammunition depots will gradually run dry. Russian artillery units will be forced to ration their shells, armored vehicles will have to limit their maneuvers, and reserves will not be deployed to active sectors in time. Furthermore, Russia is now forced to redeploy additional air defense systems to secure the Kerch Bridge, Taman Station, and the remaining rail routes. Every S-300 or S-400 battery pulled from other sectors to cover Crimea automatically creates a new gap in Russian radar coverage elsewhere on the front. Even the alternative rail line running along the Sea of Azov coast offers no real safety, as it passes much closer to the front line through Mariupol and Melitopol areas under constant surveillance and well within reach of Ukrainian strike systems. This is where the true strategic weight of the operation lies. Ukraine did not just destroy another logistics convoy, it is turning Crimea, once considered an impregnable fortress, into an isolated, suffocating pocket where every supply train and truck must run a gauntlet exposed to destruction. 9 low-cost drones successfully bypassed advanced electronic warfare systems, destroyed tons of ammunition and fuel, and shattered the Kremlin's narrative that the entrance to Crimea was entirely secure. This train will never reach its destination, its shells will never feed the guns in Zaporizhzhia, and its fuel will never power the armor in Kherson. In a span of just 90 seconds, Ukraine paralyzed the entire Russian logistics network at the gates of the peninsula.